because all the x's are to even powers, we're going to test whether this function is in fact even or not. To test for even, you take x and you replace it with negative x. So I'm going to take wherever I see an x, I'm going to replace it with a negative x. Now, a negative to an even power is a positive, and I'd have the 6. That minus 3 is outside, so that just comes down. But this negative right in here squared makes that a positive x to the second. Does that match my original? So that means this is an even function. So we're testing for even, odd, or neither. Okay, this is number 25. Then we're going to look at one like 27. I see that they're not all even powers of x because this is to an odd power there. There's one even and one odd. So I doubt it's going to be even. If you don't mind, I'll check whether or not it's odd. To check for oddness, you replace x with negative x. You also replace y with negative y. So right now, I have this as my original. What I'm going to do is I'm going to leave wherever there's an x or a y, I'm going to leave it blank. Now I'm going to replace the y with negative y and these x's with negative x's. Negative y stays negative y. Negative x stays negative x. You still have 1 minus, but what happens in here if it's to an even power? It goes back to positive. So we have this. At which point, I need to see, I don't want negative y, I need to compare it to y. So how do I change this from a negative y into a positive y? So if I was to multiply both of these by, I don't know, how about a negative 1 and a negative 1? Now I'd have y equals x times this radical. That matches the original, so this is in fact an odd function. Now, a lot of people struggle here. Guys, if I have 2 times 3 times 4, if I have 2 times 3 times 4, do I take the 2 times both of them or just one at a time? You just one at a time, right? So this negative 1, I'm only multiplying by that to make it positive, right? Okay, if we move to 39. 39 is a good question. It's called a piecewise function. They're going to ask for 3 things. These are the 3 things that they're asking for. Let's start with A, which is g of 0. G of 0. Is 0 greater than negative 3 or less than negative 3? It's greater, so I use this function. So if I put in a 0 plus 3, what do I get for that one? 3. So basically, I'm just plugging it into the first one, and I get a 3. Everybody know why I plugged it in there? Because 0 is bigger than negatives. And let's do B first before we do C. On B, what's on B? It's g of negative 6. Negative 6. Is that bigger than negative 3? No. Think of a number line. Negative 6, negative 3. It's to the left, isn't it? So I don't want to use the top one. I think I want it to the left of it, don't I? Or less than? So if I put a negative 6 in here, what result would I get? I'd get the negative of a negative 3, which is a positive 3. Finally, for part C, it's g of 3. Is the last one is? Okay, this is g of negative 3. Negative 3. Now, is -3 bigger than -3, bigger than or equal to -3, or less than -3? I believe it's the equal part, right? So if you put -3 into here, what would you get out? 0. Any questions on symmetric? Even is y-axis symmetric. Kind of like an x squared graph. That's an even, because if you fold it on the axis, y-axis, they'd match up. An odd, on the other hand, an odd is origin symmetric, which means you'd have to fold it on the x-axis and the y-axis. So if you folded this on the x-axis, this part down here would now be up here, right? Now fold the y-axis, would these match up? Okay, how about this one? If I fold the x-axis, all this down here is going to move up here, right?
Yes.
And then what? If I folded it on the x-axis, would these points match up? So I think this one is in fact an odd function, just based on the graph.